Okay, thank you everyone for joining August CSSSA webinar. Today we have Arianna Salazar-Miranda. She will talk about 15-minute city quantified using human mobility data. I will briefly introduce Arianna. I was really excited when Arianna accepted giving a talk at the webinar because I met her last month at the Santa Fe Institute workshop, and when I heard her research, I was like, oh my God, this is amazing. I really love her work. So I'm so honored that you speak to us today. To briefly introduce her, she's assistant professor at Yale School of Environment. Her research examined the interplay between the built environment and human behavior and sustainability using computational methods and new data sciences. She's also interested in developing digital tools in collaboration with cities and communities to foster more sustainable urban environments. Arianna, the floor is yours.
Thank you, Jin, and thank you, Tim, as well for inviting me today. I'm very excited to share some of my latest research. I know this is a transdisciplinary audience, so hopefully I'll get many of you excited about thinking about cities. So today I'm going to talk about quantifying the 15-minute city using mobility data, and I'll be thinking about its social and environmental trade-offs. So let me start with sort of the big picture motivation, right? We know that cities are significant producers of carbon emissions. In the US, transportation is the largest contributor. It produces around 38% of all emissions. And within that, personal vehicle use makes up the majority of those emissions by a significant margin, so around 58%. And so this translates into personal vehicle use, generating around 1.2 billion metric tons of CO2 per year. And so therefore, any policies that aim to reduce personal vehicle use have the potential to lower aggregate emissions considerably. And so part of the reason why personal vehicle use is such an important source of emissions is that Americans travel really far distances to do their daily activities. And so you would think that this is mostly driven by long commute times, which in the US are around 30 minutes. But this is also very much a problem for other routine daily activities, such as, for example, shopping trips and business trips. And so, for example, here in these graphs, you can see that the average length of a personal shopping trip is around 7 miles. And the same holds true for personal business trips. So, for example, going and getting your hair cut or going to the post office. And so these facts beg the question of why do people travel such long distances, right? Not only as part of their commutes, but also in their daily lives. And so part of my research agenda explores these questions. In particular, I study how the way in which we build and design our cities has been an important contributor to this problem. And I've explored two different aspects of city design that can influence travel behavior. So on the one hand, I've studied the role of layouts. And so this part of my work studies how the curvilinearity and the disconnectedness of street layouts that we use to develop suburban neighborhoods ended up increasing commute times and associated emissions. But the second aspect, which is the focus of the paper that I'm presenting today, has to do with the distribution of land uses and the location of amenities within cities and how these affect travel behavior. So the idea here is that many people have started to think about how can we curb emissions by redesigning a city's internal configuration. And so, for example, by fostering mixed uses, or for example, by densifying some areas of the city. And one prominent and recent example of this type of thinking is precisely the 15-minute city model. So for those of you that are unfamiliar or have never heard of this model, the basic premise of the 15-minute city is that if everyone had access to basic services within a 15-minute walk, people would use sustainable transit more, creating more livable and walkable cities, and in turn, of course, lowering transportation emissions and congestion. So this model was first introduced by Carlos Moreno in Paris during Mayor Anne Hidalgo's re-election campaign, which happened in 2020. And although it may seem like a relatively new idea, it actually has its roots in planning ideas that have been around for a much longer time, right? And so for those familiar with sort of the planning or urban planning field, these include ideas around sort of transit-oriented development, around Clarence Perry's neighborhood unit, and even more recently, it connects to the ideas of the new urbanism movement. So the 50-minute city has also gained popularity worldwide, and now cities in the US like Cleveland, cities like Detroit, Portland, and of course, many European counterparts have announced that they want to become 50-minute cities. And so why is this? Well, policymakers are starting to embrace this as one alternative that allows them to reduce urban congestion and transport-related emissions by trying to just make people rely on amenities and services that are closer to where they live. So in this work, our objective is pretty straightforward, where our aim is to study the 15-minute city model and explore 3 interrelated questions. So first, we're interested in describing how far is the US from the 15-minute city ideal. Second, does access to amenities actually improve local usage levels? In other words, does having more access to amenities nearby actually makes people use them more, as proponents of the 15-minute city idea would expect people to do this? And then finally, what are some of the trade-offs, and in particular, social trade-offs of adopting the 15-minute city model? So to do this, we're going to leverage large-scale GPS data, which is going to allow us to measure in great detail the trips that people take locally within a 15-minute walkshed. And just to give you sort of a teaser, I'm going to provide you with 3 sets of results. So first, I'm going to show you that the US is still far from achieving the 15-minute ideal. We find that only around half of Americans take 14% or fewer of their trips locally. Second, we show that the lack of access to local amenities is partly to blame for why local usage is so low. And conversely, we show that access to amenities, for example, by releasing zoning constraints, can be a powerful policy lever to achieve the 15-minute city model. And then finally, I'm going to show you that implementing the 15-minute city has important trade-offs. And in particular, I'm going to show you that one worrying concern is that more local living can generate more experience segregation, especially for low-income residents. So let me get started by giving you a brief description of our data. So we obtained our mobile GPS data from SafeGraph. SafeGraph is a company that integrates data from different smartphone apps. And so, for example, think of apps like Google Maps, weather apps, or any other apps that are working both in the back and front of your smartphone. The data includes around 10% of smartphones in the US. It covers 420 cities and represents 13 billion trips to points of interest, or POIs, taken by 40 million people during 2019. We are going to observe monthly aggregate flows of trips between home census block groups and individual POIs. Compared to the census, the data is representative across different demographic groups, such as age, and it also closely matches population counts. And this is going to be particularly true when we aggregate across neighborhoods or larger geographic units. The high coverage presumably reflects the high penetration rates of smartphones in the US across all population segments. But of course, these data might not fully represent individuals who just don't use a smartphone, or also those users who opt out from sharing their location data. So we're going to use this large mobility data set to understand how far the US is from achieving the 15-minute ideal. Our first ingredient is going to be constructing a measure of local usage. So we're going to define this as the percentage of trips to amenities from each census block group that occur within a 15-minute walk from its population-weighted centroid. We are going to focus on trips made for essential consumption purposes, and we're going to focus on 9 categories. So the first one is services. So here, think of banks, schools, restaurants, religious places, parks, health, grocery stores, and then last we have arts and culture. So one important thing to note here is that we do not have information on the travel mode. But I think it's reasonable to expect that trips that are taken further away from 15 minutes are probably taken by car or public transportation. So let me here illustrate how the usage measure works with this example. So in the figure in the slide, I'm plotting the 15-minute walk shed for Hyde Park in Chicago, and I'm showing it with a green dashed line. And then you see the percentage of trips falling within that walk shed belonging to these 9 categories that I outlined. So in this particular example, Hyde Park has a local usage of 18%, and I'll show you later that this is actually pretty comparable to most of the US. So let me here start by showing you how our local usage measure varies across cities in the US. So here, the color corresponds to the share of trips taken within a 15-minute walk shed. Green is reflecting higher local usage, and red reflects lower local usage. And as you can see, there is a clear regional divide, right? Cities in the Northeast have an average local usage of 34%, which essentially means that residents of these cities take 34% of their trips within 15 minutes. And instead, you can see that cities in the South have a much lower local usage. It's around 18%. We can also look at a selected group of cities. So in this graph, you're seeing that New York, as we would expect, is far ahead from other cities. It has a local usage of 42%. And then in contrast, we have cities like Atlanta or Burlington that have a local usage of 10%, which is among the lowest in our sample. So as a whole, our data shows that Americans take only a very small fraction of their trips locally. So here in this figure, I am plotting the cumulative distribution of local usage across all census block groups, or CBGs. And I'm showing that the median is only 14%. So this means that 50% of Americans reside in CBGs, or neighborhoods, where people take 14% or fewer of their trips locally. So in a nutshell, the US is still far from satisfying the conditions of a 15-minute city. So then the natural next question is, what can be done to improve usage? Is it possible to improve the low levels of local usage by increasing access to amenities? So in this next section, our goal is to explore how important access is in explaining the vast differences in local usage that we observe both across cities and across neighborhoods. So as I briefly mentioned before, the basic premise of the 15-minute city model is that providing access to local amenities can, in fact, induce people to make more local trips. And so from a planner's perspective, this can be achieved with some of the tools that we have available at hand. And so, for example, we can use zoning or we can use business incentives. But the reality is that these policies will only be successful if access actually increases usage. And while in principle, this might sound natural or obvious, there could be many reasons why access wouldn't necessarily increase local usage as much as the proponents of the 15-minute city model expected to. So for example, people could have just idiosyncratic preferences for specific amenities independent of how far these are from their homes. So imagine that you are a P.F. Chang lover and that you are unwilling to substitute it for any other nearby restaurant. So this form of love for variety would limit the effects of access on local usage. A different view also argues that driving is just deeply embedded in American culture. And so one would expect people to not respond to access by driving less. And so to test this idea, we constructed a measure of local access that summarizes the availability of amenities within a 15-minute walkshed to the same 9 categories that I introduced before. So here, for each of these categories, we're going to compute the neighborhood percentile in the distribution of the count of amenities across all US neighborhoods. And we're then going to average these percentile ranks across categories to obtain an index that lies between 0 and 100. So our index is going to be close to 0 for a neighborhood that is at the bottom of the amenity distribution for all categories. And it's going to be 100 for a neighborhood that lies at the top of the amenity distribution for all categories. So you should think of this index as sort of a measure of well-rounded access, right? To rank high, you kind of have to have enough of each of all of the amenities. So let's start with the figure on the left. So here I'm showing you a comparison across cities, and I'm plotting local usage in the vertical axis against access in the horizontal one. And we can see that access has a large explanatory power, and it explains around 80% of the variation in usage across cities. So for example, let's take a closer look at San Francisco and Atlanta. So you can see that these cities both fall on the regression line. And so moving Atlanta from its current access level, which is around 30, to the level of San Francisco, which is around 70, would increase local usage from 10 to 30%. Now, if we go to the right panel, we see that this relationship between access and usage also holds across neighborhoods within cities. So in particular, differences in local access explain around 70% of the variation in usage within a city. And if you think about it, it's pretty remarkable that at this smaller level of disaggregation, access continues to be such an important determinant of local usage. So this relationship between access and usage is robust to controlling for population density, distance to the city center, fixed effects, and a host of social and demographic characteristics of neighborhoods. So overall, this strong positive correlation supports the idea or the hypothesis that increasing access might in fact reduce average trip times. But of course, as of now, this correlation is only descriptive and therefore might not be causal, right? And so distinguishing sort of between these two is important because if access has a strong causal effect on usage, then policies that increase access will increase local trips, contributing to a more sustainable planning model. But let's think of some of the reasons why this relationship might not be causal and sort of how to account for potential confounders. And so I find it helpful to think this through using a causal diagram. So the basic problem is that we're interested in the causal effect of access on usage. The problem when estimating this relationship via OLS is that there might be other confounding factors that might affect both access and usage. So for example, imagine that in a neighborhood, we have a huge community of local living enthusiasts. So these are people who dislike cars and just love walking everywhere. And so naturally, we would see that high rates of local usage in this neighborhood. But then now imagine that the presence of these local living enthusiasts also creates a demand for more local amenities, which in turn also incentivizes developers to cater to this demand. And so as a result, you would see in the data that this neighborhood has high access level 2, right? And so in this story, access is not really causing usage, but it's the composition of the neighborhood that is driving both access and usage. And so to address this concern, what we do in the paper is we leverage historical variation in zoning across New York City neighborhoods that stemmed from the 1961 zoning resolution. So the idea here is that historical zoning laws impacted access, but these historical zoning laws are unaffected by high usage residents being attracted or attracting businesses. And so we can estimate the effect of zoning laws on usage via access. So the exclusion restriction here in the setting is that 1961 zoning only affects contemporary usage via access. So let me give you a little bit of additional context on the 1961 zoning resolution. So this was a policy that established citywide floor-to ratio regulations, also known as FARs. And essentially, it divided New York City into 378 commercial districts. So here I'm showing you in this figure the commercial districts with the different FARs, which you can think of as a measure of density. And you can see that it ranged from as low as an FAR of 0.5 up to an FAR of 15. And so this is sort of a case of incentive zoning, where developers were allowed to build at higher densities if they also provided commercial uses as part of their developments. So as sort of to give you a little bit more of a historical context on the motivations behind this zoning, so the decision to zone sort of one way or another primarily responded to two sort of major forces. The first one was just the existing densities that were already in place. And the second thing was they were sort of also following neighborhood borders or jurisdictions. And so we can use it as exogenous variation in present day access to amenities and services. So the first step is I want to show you the relationship between our contemporary measure of access and this historical average FAR for neighborhoods in New York City. So this first step, or this figure, essentially establishes the predictive power of our instrument. In other words, how well can the historical average FAR explain the contemporary variation in access? And you can see that there is a strong first stage with an F statistic of 187, which essentially is telling us that neighborhoods that historically had fewer land use restrictions or a higher FAR see higher levels of contemporary access within a 15-minute walk shed. So here I'm showing you our results. You can see the table reports the OLS and the IV estimates for New York City neighborhoods. Our dependent variable in all the specifications is local usage, and the explanatory one is access. So in the first column, I'm reporting the OLS estimates, and it shows that a 1 percentile increase in access corresponds to a 0.95 percentage point increase in 15-minute usage. So essentially, this means that taking a city with the access index of Tallahassee, and I don't mean to be mean on Tallahassee, but it is a low 30, and increasing it to the level of Chicago, which is around 60, would be associated with a 28 percentage point increase in local usage. Now, if we move to columns 2 to 4, these show our IV estimates controlling for a host of geographic and demographic variables. So we're controlling for distance to the city center, baseline population, housing density, and many other covariates. And here we're basically following prior work by Schertzer and Twinem, who've noted that some of these specific dimensions might also have affected the decision to zone one way or another. So our preferred specification is in column 4, which reports or shows that a 1 percentile increase in access is associated with a 1.23 percentage point increase in local usage. And so going back to the example of Tallahassee and Chicago, the IV estimates now imply that this increase in access causes a 37 percentage point increase in local usage. So this is a sizable effect. If you remember that I showed you before that the median local usage is 14%. Of course, this is extrapolating a little bit because these IV estimates are only for neighborhoods in New York City, but reassuringly, they're quite close to the OLS estimates for the entire US. So the IV estimates that I just showed you suggest that increasing access causally increases local usage. But these estimates are cross-sectional, and so they cannot distinguish between two competing explanations that have very different policy implications. So on the one hand, our results could be interpreted as access directly affecting the behavior of incumbent residents. That is, people who live in a neighborhood with improved access are actually changing their day-to-day travel behavior in response. And so if this is the correct interpretation, then one would expect policies that increase access to actually create a net reduction in aggregate emissions associated with transportation or with how people move around. And so a second interpretation, which our IV estimates cannot rule out, is that the effects of access are simply driven by the fact that neighborhoods with more local amenities end up attracting residents who just prefer to travel smaller distances, while just residents that love longer travel are just getting pushed out over time. And so in this case, our estimate would still be causal, but they would be reflecting a sorting mechanism. And this distinction is quite important because if our findings are driven by sorting, then the aggregate effects of this policy or a 15-minute city policy would be limited, right? If one improves access in a neighborhood, then what we essentially would be doing is just reshuffling people around across neighborhoods, but it wouldn't necessarily reduce the national level aggregate emissions. And so I'm not going to go into the details in the presentation, but in the paper, we provide some suggestive evidence that is consistent with the view that zoning changes incumbents' behavior and that the effects that we find are not just due to sorting. And so just to give you sort of a brief summary here, what we do is we focus on a subset of New York City neighborhoods that experience the least amount of population churn. And we show that our IV estimates remain very similar when we estimate it on this subsample. And so in a world where our estimates are driven by sorting, then we would expect to see no or weaker effects on this sample. So far, I've shown you that there are stark differences in usage across the US, and that access can explain a lot of its variation. And I've also shown you evidence suggesting that there is a causal relationship between access and usage. And so now, what are some of the social challenges of adopting the 15-minute city model? So some have expressed concerns regarding the local nature of 15-minute city and the negative consequences that it may have if we stop connecting with one another. And so Ed, for example, said that the 15-minute city is a dead end. Cities must be places of opportunity for everyone. So in the last part of the paper, we explore the potential trade-off between the idea of local living and social interactions. So one particular worry is that trips taken far away from home, like the ones that I'm showing here with an orange line, may offer unique opportunities for face-to-face interactions with people of different social classes. And so when we induce local trips within a 15-minute walkshed, we risk losing or cutting out all the diversity that comes with those interactions. So this might be particularly relevant in light of new evidence showing the effects of social interactions on social upward mobility. So to shed light on this, what we did is construct a measure of experience segregation, which we compute as the sum across POIs of two terms: the frequency of trips by residents of the neighborhood I to each POI times the similarity of people visiting that POI. So as our measure of similarity, we use 1 minus the normalized Euclidean distance of the average income between residents of neighborhood I and those visitors to POI P. And so our measure of segregation is going to be high when people visit points of interest that are also frequented by others who have a similar income. And it's going to be low when they visit POIs that are frequented by people of different incomes. And so just let me give you an example so you get the sort of the intuition of the measure. So imagine that there is a rich neighborhood in Chicago. And suppose that when people travel outside of this neighborhood, they only visit high-end restaurants that are also visited by other rich people from other neighborhoods. So in this case, the experience segregation for residents of this neighborhood would be high. In contrast, if these people also visited parks that are frequented by people from various incomes, then we would say that the experience segregation of their neighborhood is low. So then we can use this measure to explore if neighborhoods with a higher 15-minute usage have higher levels of experience segregation. So here, this first graph, I'm showing you the relationship between between experience segregation and a 15-minute usage. And I'm plotting this separately across neighborhoods of different income levels. So I'm showing the top quartile in blue, the second one, third one, and then the bottom quartile in orange. So you can see that for the low income, high local usage is correlated with higher social segregation. That is, for the poor, staying local comes at the cost of higher isolation from socio-economically diverse people. So in particular, for low income, segregation increases from 71 to 76 as we move from neighborhoods with the lowest 15-minute usage to the highest. And so here, just to give you a sense of the magnitudes, this is almost an entire standard deviation, suggesting that this trade-off is a meaningful one. For the higher income, however, we see that higher local usage is associated with lower experience segregation. That is, for people from affluent neighborhoods that take more local trips, they're actually more socially diverse on a day-to-day basis. So to explain this result for the rich, we can take sort of a deeper dive into their travel behavior. So here in this figure, I am plotting the experience segregation of residents from neighborhoods with different incomes, but I'm doing this conditional on taking a trip within 15 minutes, which I'm showing you with the green line, and conditional on taking a trip outside of the 15-minute radius, which I'm showing you in orange. And we see that for the low income group, trips outside of the 15-minute threshold provide a significant source of socio-economically diverse encounters. Moreover, you can see that the green line is always above the orange line. So this suggests that we experience more segregation during local trips than we do on trips taken outside of the 15-minute watershed. But the key point here is that the gap between the green and the orange lines, which essentially is measuring how many connections we lose when we go local, is larger for the poor and smaller for the rich. Now, when we look at higher income neighborhoods, we see a very different pattern. Higher income neighborhoods experience similarly high levels of social segregation, both inside and outside of the 15-minute watershed. So taken together, this evidence suggests that there might be a trade-off between local living and segregation, particularly for residents of low-income neighborhoods. So to conclude, we provide the first large-scale assessment of the feasibility and trade-offs of promoting local living in U.S. urban areas. We introduced a measure of 15-minute usage, which allows us to see how much people actually rely on their local amenities to fulfill their daily needs. Using this measure, we conclude that the U.S. is still far from achieving the 15-minute ideal. We also document that improving access can be a powerful policy lever for inducing people to take more local trips. And finally, we showed that localized trips may exacerbate social segregation, particularly for low-income residents. And so in the couple of minutes that I have left, I was hoping to show you a very, very short video that summarizes the project probably better than I just did. So let me just play it for you. See. So this was a collaboration between MIT Sensible City Lab researchers and also the Pedro Cruz, who's a fantastic faculty there doing the visualization work at Northeastern. Yeah, thank you so much.